So my name is Maria Nagy, and
Hello.
I am the owner of sciencenerd. And today we have a special guest. She's going to tell us about her work, Lorena Gonzales from Mexico, and she's a geospatial engineer, and she loves maps, and she works with plants, wheat fields, wheat fields. Am I correct? Kind of? No?
Yes.
Introduce yourself. Thank you.
Yeah, that's about it.
Thank you for being here, or thank you for doing
thank you.
this.
Yeah. So
tell us about what you do, where you're located.
yes, I'm in the north of Mexico in Sonora, and I work with wheat fields and mapping them with a drone. And I will tell you, like I have a presentation where I will show you some pictures, and I hope you like them. um, okay, I will share my screen. Oh, I can't. Do you think you can
Right now.
allow me to
Right
share
now.
right now? Okay.
Okay, sure. It should be you now.
Screen.
One.
Yeah. Can you see my screen?
Hold on 1 second. It disappeared on me. There we go. Yes, I can see your screen.
Okay. Okay. So I will start then. So hello, I'm Lorena, and hopefully I can entertain you a bit with cool drone pictures. Just talk about a little about the wheat and how it is spying on plants, and a little about the light, that we need the light to take the pictures, right? So so the wheat needs resources to grow, and at certain stages it's more important to have them to nitrogen, water, some nutrients. And I have been assistant in a research station where they make trials of wheat. So if the wheat has all the resources it has, it's happier. Otherwise, it stresses. And they are trying to select the varieties and where the wheat is happier, so they can give more yield and feed like more people. So the scientists can measure how green and big the plant is with sensors, aka cameras, and they can do it by having them like right in front of the plant, walking, carrying them, or okay, so quantitatively, that's the objective is to know with a number how well the plant is doing, instead of just saying like, this one looks better. So with a number, you can score them and say like this, we'll continue with this one.
Hold on 1 second, okay?
Mhm.
It's acting up. Okay.
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 Okay. Very good. So with these measurements, they can select quantitatively which trials with which varieties they will continue in the next round of trials, and do science things like predicting yield, for example. So it's like spying on plants. And to have a better view, instead of having the camera next to the plant, you can send a flying camera to spy from above. We have used drones like this, for example. And this is the kind of images that you can get with the drone, and you have a way better view from above, faster to take the data. And here is like working with the remote control, checking the drone, sending the flight plan, and to the left is the what we can see in the screen when checking the remote control for the drone. We have a preview of the drone cameras is capturing, and all the like flying details about the aircraft. It's cool. So from above you can see patterns that in the ground they are not so obvious, and we can detect, these are farmers field, not trials, but we can detect like irregularities and find out why they happen and fix them if it can be done. So this was the team last year. It was a girls team. And also you can fly yourself to spy on the plants. Like we put a camera on a small airplane, and there is the pilot and me. So these are nice cameras. So there are a lot of options to spy from above the fields. So cool, yes. So you can take the pictures. Sometimes you can zoom in and get a lot of details. You can spy from the mountains. There we are in Oaxaca mountains, checking with another team on Malawi's experimental fields. And there the kids love the small drones. We use their schools as landing strips for the drone. Okay, so these pics are nice, okay, but what's this? Something looks strange in this one, and even more strange on this one. So we can start talking about light. In the first picture, we see like a normal picture. That's the light we see. But yes, the light is, if the light is white, why not everything we see is white, right? So the things act like small mirrors, not perfect mirrors, but they reflect light. So for example, this apple looks red in my eye because from all the light it takes, it reflects back more red light. So what I can see is the light that is coming back from the object. So I see the apple red. And so for different materials, they reflect the light. So the tomatoes look red because they reflect back from all the white light, they reflect back the red light. And the other one, they absorb it, for example. The bananas, they reflect, yes, red and some green. And the blueberries, they reflect back the blue. And the grapes, they reflect red and like violet. So they look different because of the materials, they reflect like different light. So is there something beyond these red to violet colors? Yes, there's light we don't see all over the place, like all the radio, microwaves, infrared, ultraviolet, X-ray, gamma rays. It's a whole different story. A lot of light. So for the agriculture, we focus on the nearest to the red. It's the near infrared. And this again is a normal photo, the light we see. And this one is an infrared photo. You can see, for example, my pants are violet, my blue, no, morado. When infrared, it all looks like strange. But we just said that we can see infrared. Yeah, but we can paint it with another color. Here, we painted it from black to yellow to white. The camera can see it, but we don't. But we can paint it with some other color, like in these night vision glass lenses that they painted green if there's a lot of light. So why we measure with the camera? We can measure it like to know more about the plants. This darker green belongs to a healthy leaf, mapping how much light it reflects in the blue light from 0 to 1. If it reflected all the light, the graph would be way up. In the yellow, how much light, and the red, how much light. So a healthy leaf reflects 0.5 of the green light that it receives. But in the infrared, from this arrow to the right is what we can, the information we can get from the plant in the infrared. This would be only the visible, but from the infrared, we can get a little bit of different information. The healthy leaf reflects more infrared, the near infrared, and the stress leaf reflects less infrared. And the difference is very, very clear. And it's actually the opposite in the visible spectrum. The stress leaf reflects more red, more red, and then the healthy leaf reflects less red. So that's why we measure infrared with the plants, because it gives us more information to know if it's healthy or stressed. So we can measure with the camera. We can measure how much in the red the light is reflected, how much in the near, and we can see like the healthy reflects more infrared and the stress less infrared. So we can mix this in a formula and get what is called vegetation index. So we get this number for each pixel of the picture actually. So we have, again, this is a photo of the crop in normal color, and that's how it would look like this vegetation index map. It includes the infrared, but since we cannot see it, like we mix it and we display it in the color that we want. So the green for the more infrared, and the red for the ones that reflects less infrared. And the difference can be like very subtle, but for measuring the health of the plant, it helps a lot to have infrared. So we are back at the beginning with this quantitative measurement is given by this calculus, the vegetation index, and this helps to select trial winners quantitatively, and yes, and this helps to select which trials do better. So I will, if you have 1 minute more, I can share the drone landing. Let me pause and share my screen. I have a video of this is the camera of the drone. Can you see my screen still?
I see the slide deck, yes.
The slide. Do you see like the sky and the field?
Yes, yes.
Yes, okay. So it's just short videos of the drone landing. It was an event.
Are you flying the drones in this, or who's flying the drone?
It's a bit automatic. So we upload the flight plan, and then it just goes and
Wow. Oh, that's awesome.
Okay, so this is a little bit of plant mapping plants for research purposes.
That is amazing. I mean, I bet it's so fun working out in the field all the time. And
yeah,
how did you get involved in that?
After I finished school, there was like they were looking for somewhere with this profile, someone who know about geospatial stuff, geographic information systems. And in the school, my teachers told me to apply for this job, and I followed the process, and I got here. This.
That looks super fun. That looks amazing.
Yeah, the pictures. I love the pictures of the drone. Yes.
Yeah. Yeah. I'll have to try to introduce you to another guy that's also into geospatial, but he's a programmer coming out of Harvard. I'll introduce you to him because you might have some things to talk about there. That's very cool. So is it AI technology that's doing the math, or did you guys manually program the math? So when you have a picture with all these different pixels, is it a program? I guess it's a program that measures the intensity of the pixels and then translates that to a formula, which tells you which plants are healthier than the others. It gives you that score. Okay, we did something similar with our diagnostic technology. We built a phone app that measures the pixel intensity of the lines, and then it'll quantify it, and then that'll translate into if it's positive or negative. So that's very cool. And you get to fly and you get to fly all the time too in the
plane.
Yeah.
That was before the pilot. He agreed to make a hole in the bottom of the plane, and that for several years that was working. But I think he retired now, so the drone is now the alternative.
That's amazing. That's amazing. I love all the pictures and everything. And even though my science is a different type of science, so I appreciate that I learned bits and pieces of this when I was in school about the light intensity, but I appreciate you breaking it down like that. So yeah, that's very cool. So do you continue?
Yeah,
Do you
yeah.
think you're going to continue with the project?
Cool.
Do you think you're going to continue with the
I am
project?
not already not in this. I am in like in different areas. I think I'm starting in different areas now. Just still work a little just for this in winter is when winter wheat is in the fields. So I am still involved in that during this stage, this season. And the rest of the year I'm doing something completely different. Yes. So let's see what.
Okay, I'm going to upload thank you very much for doing the presentation. I'm going to clean it up and then I'm going to upload it and then people can do Q&A via text if they have any questions.
Sure.
So,
Yes.
yeah.
Yes.
Okay, so I'm going to stop recording now and then we'll just continue talking. Okay?
Okay.
Thanks.